Welcome to GeoGebra Lab number 14. We'll start by putting some points on the sketch. C is 1, 4. P is 5, 2. And P prime, I'm going to use P apostrophe, is 13, negative 2. We've seen the prime notation before. The prime notation usually signifies an image. And yeah, that's going to be the image of the point P after a dilation. So now we're going to find the lengths of CP and C prime. So let's do it the other way first. Let's do C to C prime. That length is 13.42, and C to P. And we're going to calculate the ratio between those. You can just stick those numbers in a calculator and do it that way. I'm going to do it this way. I'm just going to say S is equal to, and I'll just type in C P prime divided by CP. And that tells us the answer is 3. So now we're going to make, and this is called the scale factor. 3 is the scale factor of this dilation. The C is the center of dilation, and the scale factor means that it moves the point P to P prime with a factor of 3. So now we'll use a triangle and see what a dilation does to a triangle. So we can make a triangle ABD with the point 2, 5 is A, B is 4, 4, and C is 4, 3. I'm sorry, that's D. Okay, let me move this out of the way so we can see it. Oops, I don't want to move D out of the way. I want to move that out of the way. There we go. So we're going to use dilate from point tool. That's in the transformation toolbox. And it tells us what to do. Select the object, then the center point, and then the factor. So I'll select the object, the center point. And for the factor, we're not going to type in a fixed scale factor. We're going to type in a variable. I'm just going to call it F. And yes, we're going to create a slider. So this slider right here controls how big F is. So the next step is we're supposed to make the scale factor the same one that we found in B. Well, we found the scale factor from B to be 3, so let's move this. Whoa. Okay, so let's make this 3. And let's measure the distances like we did before and see how this is affected. Let me center this up a little bit. So the distances from C to A prime is 4.24, and from C to A, 1.41. So yeah, maybe this thing could have the same ratio. Let's stick it in a calculator if you want. I'm just going to do this again here. C to A prime, CA prime divided by CA. And yes, the answer is the same, that this distance here with the same scale factor, it kind of makes sense, is 3. But now let's check the scale factor of these two similar triangles that were created. Okay, so let me move this out of the way. So we're going to find the length of this side, A prime, B prime, and AB, and compare those ratios. So this one's 6.71. This is 2.24. Can you see it? Can you see it? What do you think that's going to be? And yes, the answer is what you expected. The side lengths have also changed by the same factor that the scale factor of the dilation was. So for the last question, you'll put another point. R prime is negative 2, so I'm going to click with a point right there. And here, let me rename this. By the way, to rename a point, you can just start typing after you make the point, R prime. I didn't have to click anything else. I just started typing R prime. So here you're supposed to find if this is the image using the same scale factor and the same center of dilation, C, you're supposed to figure out where R is the original point. So when you do that and enter the information that you need to in text boxes, you're done at the lab. Enjoy.